Hi friends, welcome back to new session. In the last session, we started characteristics of DC motor and explained N versus IA curve, T versus IA curve, N versus T curve for DC shunt motor. Now in this video, I'll be discussing those characteristics for DC series motor and cumulative compound motor, differential compound motor. Let us see first of all DC series motor. Okay. In DC series motor, your field one is connected in series with armature or in series with, I can say, supply. Since it's a motor, direction of IL, line current will be like this, direction of ISC will be like this, direction of IA will be like this, okay? Because motor always takes current from supply from the, it takes current from the supply, no? That's the reason, okay? IL, ISC, IA. And guys, V equals to EB plus IA, RA plus, see, I'm just applying simply KVL equation for this loop. V equals to back EMF. I already told you in a motor, because of generator action, back EMF is developed. V equal to EB plus. In this armature, some resistance will be there. Armature winding will be having some resistance, having resistance RA, IARA plus series field winding having resistance RSC, ISC, RSC. Series motor, IL, ISC, IA both are same. Everything is same, okay? And V equals EB plus IA into, in place of ISC, I'm writing IA once again, IA into RA plus RSC. Okay, this expression you know how to write. And if you want to draw N versus IA curve, first of all, you should know N, what is the expression generally for N proportion EB pi, In place of EB, what I can write here from this equation, V minus IA into RA plus RSC I can write by flux. Guys, previously we seen it for DC shunt motor, I explained N versus IA curve, T versus IA curve, N versus T curve for without armature reaction and with armature reaction. But for series motor, instead of explaining without armature reaction with armature reaction, so let me discuss unsaturated region and saturation region. That means without saturation with saturation. In unsaturated region, how N versus IA curve will be look like, and how T versus IA look like, and how N versus T look like. Similarly, how N versus IA, T versus IA, N versus T looks like in saturation region, that also will see. Because here say field winding is connected in series with the supply. So as whenever mechanical load which is applied to the series motor is increased, whenever load increases, current taken by the motor also increases. That is common sense. But here your field winding is connected in series with the supply. So obviously what I need to write here is your flux, nothing but series flux depending on I can say IA value. Yes or no? Because it is connected in series with armature. So obviously in unsaturated region, pi proportional to IA is very, very important. You have to remember. As the IA increases, the flux also increases. Okay. So that's why in unsaturated region, series motor can be called as it's a variable flux machine. Okay, it's a variable flux of machine. And try to understand here one thing. N versus, let me draw first of all without without saturation means I can to say that if there is no saturation considered at that time, let me draw N versus IA curve. Okay. So if there is no saturation means what? As long as IA varying, your flux also varying. Okay. So first of all, before that, you please try to see here in this relation, RA value, armature resistance, I already told it is around 1 ohm. RSC, series field one resistance also around 1 ohm. Because these values are very, very less. No? RA, RSC values are very, very less. So whenever RA, RSC very, very less, so IA into RA plus RSC, this value is very, very negligible. I can neglect this drop. Okay. So if you neglect this drop, it becomes what? N proportional to V by, I can say, pi. Whenever the supply voltage is constant, I can write simply N proportional to 1 by pi. And I told you in unsaturation region, or if you won't take saturation into account, in place of pi IA is there. Yes, in place of pi IA is there. I can write N proportional to 1 by IA. So guys, for without saturation, try to understand N proportional to 1 by IA you are getting here. So please try to see. Here, definitely under light load condition, whenever IA is 0 or some slow values, there saturation is not there. And whenever, try to understand here, whenever IA value is 0, that means under no load condition, current taken by the series motor also, let me take approximately 0. if IA value is 0, to tell me what about N value? Infinite. Infinite. That's the reason why whenever IA is 0, I am not touching this curve to this y-axis. This value is coming somewhere from infinite. It is coming from infinite. Okay. And as usual, n proportional to 1 by a. So as IA increases, n value reduces. You are going to have a rectangular hyperbola curve will get. As IA increases, n value reduces in this manner. As IA increases, n value reduces in this manner. If I won't take a saturation into account, yes, you are going to have rectangular hyperbola. Okay guys, this is for without saturation, or I can say in unsaturation region. Now let me discuss in saturation. Everybody knows that in saturation, though load increases, though whenever mechanical load increases, though current taken by the motor increases, in saturation flux will not increase, flux remains constant. So I should write here flux equals to constant in saturation. Okay. Therefore, in saturation region, I can write in saturation region, series motor acts as constant flux machine. Okay, guys, right. Now, as usual, once again, let me proceed. You know this relation, n proportional to EB pi. In place of VP, I can write V minus IA into RA plus RSC. If you take flux as constant, okay. Already I told you, if you neglect IA into RA plus RSC, it becomes, I can write n proportional to V by pi. I told you whenever V is a constant, I can write n proportional to 1 by pi. Here, in saturation region, I took flux as a constant. So what happens to your n value also? N value remains a constant. This only I wrote here. Try to understand. N proportional 1 by pi. Whenever pi is constant, n remains constant. So that's the reason why in saturation region means at large IA value region. Wherever IA value is more, that region can be called a saturation. I can say almost all in this region. Okay, this region. So at large load conditions, at large IA value regions, so saturation will occur. So n value is a constant, therefore n remains a constant like this. This is what with saturation. So try to understand guys, under saturation condition, series motor acts as a constant speed motor. It's a very important point. Generally, series motor cannot be called as a constant speed motor. What is the reason? See, under no load condition, what is the value of a speed? Is infinite. So load, it is a full load condition, speed is reducing. There is wide range in speed from no load to full load. That's why DC series motor can be called as variable speed motor, no doubt in that. But in a saturation region, so since flux remains constant, I'm just neglecting this IA into RA plus RS drop. And almost supply voltage is constant, your N value remains constant. So obviously I can say in under saturation region, series motor acts as constant speed motor. Very important, just try to understand, okay? And here one thing you have to understand. I told you n value is under no load condition, n value is infinite, no. Therefore, series motor should never start at no load condition. Series motor should never start, series motor should never start at no load condition. What is the reason? I told you n plus EB by pi means in place of pi I can write IA value 0. So something by 0 means infinite, n value are getting infinite here. So series motor should never start at no load condition to avoid dangerously high speed. To be frank, to avoid dangerously infinite speed, okay? That's why if you observe in laboratory also, series motors are always, for the series motor, some permanent connected load will be there. Like, in laboratory I'm saying, some permanent load will be connected to the series motor. So that people, suppose, without knowing their self, if they start series motor on no load condition, speed of the series motor is infinite. So to avoid that, generally in a laboratory also, will be connecting some permanent connected load to the DC series motor to avoid infinite speed, okay? And one more thing, if you take traction applications, lifts also, yes, already permanently connected load will be connected to the series motor, okay, to avoid infinite speeds. So generally series motor is used with the permanent connected loads. If you want exam, I can give applications like traction, lifts, etc. And one more thing guys, I told here under saturation region, series motor acts as constant speed motor, no doubt in that. But generally I'm saying, generally means you should think about in unsaturated region. Okay, generally means you should think about unsaturated region. Generally, series motor is a variable speed motor. Series motor is a variable speed motor. Is a variable speed motor. What is the reason, guys? Since wide range and speed, from no load to full load. But in saturation, yes, it is a constant speed motor. Okay, so try to understand what is the question they are asking. Suppose saturation they are asking means you should go for option constant speed motor. If they won't mention saturation, unsaturation means you should take by default unsaturated region. In unsaturated region, your series motor acts as a variable speed motor. It's not a constant speed motor because there is lot of variation speed from no load to full load. No load speed is infinite, full load speed is very less. So that's the reason why series motor can be called as variable speed motor under unsaturation region. Okay, guys. Now let me go for T versus Ia, torque versus Ia. As usual, T proportional to pi into Ia relation, you know. And I told you in unsaturation, yes, pi proportional to Ia. In saturation, flux equals to constant. So I'm discussing unsaturation, pi proportional to Ia. So in place of pi, I can write Ia once again. T proportional to Ia into Ia, it becomes Ia square. So please, guys, let me draw T versus Ia graph. Okay. As Ia increases, torque increases, no doubt, but it's a I square, no. So here your variation of torque is in a parabolic fashion. So that's the reason in unsaturated region or without saturation, your variation of torque with Ia is in a parabolic fashion because I'm getting Ia squared there. And one more thing, what about saturation region? In saturation region means saturation means at large load conditions at large Ia value regions. Okay, so flux remains constant. So simply I can write if it is pi is constant, T proportional Ia. So as Ia increases, torque increases. Yes, we are going to have linear curve like this. Okay, so T proportional to Ia, T versus Ia curve is a parabola in unsaturated region. In saturation, it is a linear curve, okay? And some people will have confusion. So generally, see which motor is having highest starting torque means generally people will going for option series motor, no doubt that is correct only. But people are confusing, sir. Starting torque means they are seeing here, don't see here, okay? Because it is wrong. Starting torque means don't see here because yes, here this point is nothing but Ia value is 0. Okay, Ia value is 0. So this is nothing but Ia. Whenever Ia is 0. That is what I can say. I mean, this point corresponds to Ia value 0. 0 Ia value region, this one. Okay. Starting means don't see this region. You know, guys, formula N, generally formula for series, for motor, I can say, let me take for series motor if you want. V equals to EB plus Ia into RA plus RSE. So tell me from this Ia value formula, V minus EB by RA plus RSE. So here my question, simple question I'm asking. Under starting condition, under starting condition means wherever n is 0, that is what I get starting condition. Don't say starting means Ia equal to 0. So Ia is not equal to 0 under starting condition. To be frank, Ia is very large under starting condition. I'll tell you. Under starting condition, n value is 0. Whenever n is 0, what about back EMF? You know, from the EB equal to pi Z N P by 60A. Whenever n is 0, back EMF becomes 0. Whenever back EMF equal to 0 here, so I can write Ia equals to V minus 0 by RA plus RSE. Okay, guys. So this minus becomes 0 here. Therefore, numerator is increasing a lot. Ia increasing a lot. So please understand, starting condition means, so your Ia value is very, very large, not small. Starting means n is 0, but Ia is very large. To be frank, I had given value also. Starting current will be around 1.5 to 2 times of Ia rated. Example, if this is the value of I can say full load condition, I can say rated armature current. So he is saying that starting current is 1.5 to 2 times, almost all here. Okay, this is what he is saying. Starting current means, starting torque means you have to see wherever current is 1.5 to 2 times of Ia rated value, there you have to see. Okay, so here if you observe clearly, yes, this is what I can say starting torque. This starting torque will be around how much he has given, 2.25 to 4 times of rated torque. Okay, guys, so please try to understand. Yes, definitely series motor develops high starting torque. Okay. Therefore, wherever I need high starting torque, definitely there DC series motor is preferable. If you take example traction applications, I told you just previously when I told you. So in traction applications, some permanent permanently some some coaches will be connected to trains. Okay, so if you want to overcome the inertia which is offered by those coaches which are connected to the engine, so definitely I need more side torque. Okay, so definitely series motor develops high side torque in traction application. I can use this motor, as well as if you take lifts also. In lifts generally, lifts application, in lifts generally will be frequently start and stop operation will be there. So frequent starts are required. Suppose we'll go for first floor. From that first floor, once again we'll go for third floor, like that. So definitely frequent starts will be required. In frequent starts, definitely if you want to start motor frequently, so that motor has to overcome a lot of inertia. If you want to overcome a lot of inertia, so definitely I need more starting torque. So obviously DC series motor develops high starting torque. So those DC series motors can be used in applications where I need high starting torque, where if you want to start the loads, which are very hard to start, which are having high inertia, so definitely I need to use a series motor in a DC motor applications. DC series motor is more preferable. Okay. Right, this is about T versus IA, and let me go for N versus T curve. So it's a very mathematical approach only. So N proposed EB by relation. EB means V minus IA into RA plus RSC by pi. And I'm just discussing first of all unsaturated region. In unsaturated, I told you flux proportional to IA. So, and one more thing, T proportional to pi into IA relation is, already T proportional to pi into IA. In place of pi, I can write IA value here. So T proportional IA into IA, you'll get T proportional IA square. So why I'm doing all those things means because I need N versus N in terms of torque I need. But in this equation, N I'm having N equation is there in terms of IA. So that I should write in terms of torque. So torque proportional IA square. So from this torque equals to some constant K into IA square. So from this IA equals to what, guys? T by K under root. So in place of IA in this equation, let me substitute square root of T by K. So please, N proportional V minus IA into RA plus RSC by, in place of flux, I'll already substitute IA value here. Now, if you want, you can substitute in place of IA, yes, root square root of T by K you can substitute. Otherwise, they are cancelling with each other. See, N proportional V by IA. This IA I'm just taking for IA, V value, as well as for IA into RA plus RSC by IA once again. So V by IA minus IA cancel RA plus RSC. Now let me substitute in place of IA square root of T by K. So this is what I guess equation. I'm getting N equation in terms of torque. So guys, please try to see whenever torque is zero, tell me what about N value? Infinite. That's why I'm not at all touching this curve with y-axis. It is starting from infinite portion like this. And if there is no saturation, if torque is increasing, N value is reducing in a rectangular hyperbola like this without saturation. Okay, guys. And what about with saturation? In saturation region, I told you flux remains constant. Okay. And try to take this relation, guys. If flux is constant, I took flux as constant here. V minus IA into RA plus RSC. I think previous one I told you. RA value is very less. RSC also very less. IA into RA plus RSC is almost all negligible value. So I took supply voltage constant. So V minus IA into RA plus RSC is almost all constant. N remains constant. So guys, try to understand. In saturation region, N remains approximately constant like this. In saturation region, I'm saying, okay. Just like N versus IA curve, if you see, in saturation, it is a constant speed motor. In saturation region, N remains a constant here. Okay, guys, try to understand that one. And see, one question was asked based on this N versus T previously in GATE examination. Let us see that question. A series, try to see this that equation, that question. It was asked GATE 2002 for 1 mark. A DC series motor fed from rated supply voltage is overloaded. You please tell me, guys, when generally motor will be overloaded at a large load region only, large current only, at large current region only, your motor will be overloaded. Okay, and that he has given clearly mentioned, and its magnetic circuit is saturated. So he clearly mentioned that it is in saturation region here. Okay, saturation region. Now what is asking? The torque speed characteristics of this motor will be approximately, he's saying approximately guys, approximately represented by which curve of the figure. So guys, you have to draw this curve. This with saturation means this is the curve you have to draw. Okay. So please tell me, this curve means, you please tell among A, B, C, D, which one is correct? So obviously D is not correct and A is not correct because it is increasing here. And if it is C, this C is just like this one without saturation is without saturation. So a rectangle hyperbola that is without saturation. This white color whatever graph is there, that only your C here. And what about B? Yes, your B is nothing but with saturation. Actually, I just draw in this graph, I just drawn that B curve like this. Almost a constant, okay. But you say approximately constant means almost this one also can be taken as approximately constant. Nothing wrong here. Okay, guys. So try to understand. So your answer is what? Please try to respond. What is your answer? So among A is wrong, D is wrong, and tell me which one is correct here, B or C. So C is not correct. Where tell me option C. I mean your C is correct for what? That is correct for without saturation. In unsaturated region, without saturation, yes, it is reducing. But with saturation means you should show constant. We don't have an exact constant here. At least your curve B is there. It's almost all constant. So you can go for option B. Nothing but curve B is answer. Curve B is your option. Curve B is your answer. Okay, guys. Very simple question. Ask for 1 mark. Okay. This is what I can say. Characteristics for DC series motor. Let us see. I already given applications also. So it is used in permanent connected loads like traction applications and lifts applications also can use this motor. Okay. Let me go for DC, can say compound motor. Yeah. I told you depending on the degree of compounding, compound motors are classified into 2 types, cumulative compound and differential compound. I told you the compound machines you are having both shunt field winding and series field winding. I took example, you can take compound motor means long shunt you can take or short shunt you can take, nothing wrong. But I have taken here short shunt where series field winding is connected in series with the supply. So guys, you know in the cumulative compound motor, your total main flux is equal to shunt flux plus series flux. In differential compound motor, total flux is equal to what I can say shunt flux minus series flux. Okay guys, now let us discuss. For cumulative compound motor, I am discussing N versus IA curve. N versus IA curve if you want. This way I equal to 0 means I can take almost a no load value. This I is IA rated means almost I can take it as the full load condition. Okay. Now let us see. I am just going to explain cumulative compound motor. Tell me guys. So let me use otherwise green color only. Yeah. Yeah, as load increases, tell me current drawn by the motor, IL increases, IA also increases, okay? Whenever IL increases, definitely ISC increases, pi SC also increases, no? Pi SC increases here. And you please tell me guys, your total main flux equals to what I told, shunt flux plus series flux. Here series flux is increasing. So obviously whenever series flux is increasing, your total flux, so what will happen? Your total flux will increase, no? Increase. And you know relation proportion EB pi, whenever flux is increasing, what will happen to your N value will reduce, okay? That's why your variation of your N will be in this manner, okay? It's for cumulative compound motor. So just like a shunt motor, you are having drooping characteristics. I mean the speed is from no load to full load, speed is reducing, but there is no much more drop. If no load speed is this much, your full load speed is almost all this much, okay? Yes. And one more thing guys, what about for differential compound? This is very, very important. So this is the question asked in previous GATE examination. So there one question was asked regarding differential compound motor. Please try to understand differential compound motor. Yes, as load increases as usual, once again IA increases here, and IA increases, and IL also I told you IL increases, IS increases. I mean series flux increases, no, series flux increases. So guys, your total flux is equal to pi SH minus pi SC. So your pi SC is increasing here. What will happen to net flux? Net flux will reduce, no? When net flux is reducing, guys, net flux is reducing, total flux is reducing. What will happen to your speed value? It is increasing, no? Very good. So that's the reason why your curve is having like this, okay? So guys, please try to understand. I'm just using laser point here. Curve is, see, you may get one out. Sir, how can you say that no load speed is a finite? Very simple. Let me take under no load condition means your though there is no current through series field winding, but shunt flux is a no. So I can say if you see this relation, n proposed to be pi. So here under no load condition, though current flowing through series field winding is zero, your series flux zero, okay. But your shunt flux is there, shunt field winding is there. So I mean, just like it is acting as a shunt motor under no load condition. I already told you in shunt motor under no load condition, speed is finite value. That's why I took finite value here for differential as well as for cumulative also. Okay. Now here question is, as load increases, I am saying that speed is increasing here. See, try to see speed is increasing like this, okay, increasing like this. Now here your doubt is, I mean it is increasing, okay, but after reaching one particular value in large load conditions, in large IA region, why this increased n value is reducing and it is coming back to same speed just like no load speed. Example, no load speed is 1000 rpm, so full load speed also 1000 rpm here. You please tell me why differential compound motor, your increase as load increases, speed is increasing, and once it is coming back to I mean the same speed at full load condition, it is coming to same speed as no load speed. So tell me what is the reason why it is coming back once again to, I mean full load speed is once again becoming no load speed value. Very simple. It's only mathematical only. By using mathematical we are happening all those things. I am not using any extra controller. Any extra controller for reducing your increased speed. For decreasing your increased speed, I am not all using any extra controller. So this increased speed, it is reducing once again. So it is automatically happening. It is not by using any extra controller. Let us see how it's happening here. You know, n proposed EB pi. EB means what, guys? V minus IARA minus ISARS. You know, for this loop, it's very simple KVL equation only. By pi means what? For differential compound, pi s minus pi se, pi sh minus pi se. Now you please tell me. I told you as load increases, your pi s increases, no? Yes, increases. Very good. Pi s increases. Whenever pi s increases, denominator what will happen? It will reduce. Okay. N will increase. Okay. So up to this, okay, it is increasing. Very good. But my question here is, under large current region, okay, if you still increasing IA value, if you still increase IA value, so IARA will be increasing, ISC RSC also increasing, because you know your IA as load increases means definitely IL increases, IS increases, IA also increases. So IA are increasing, ISCR is increasing. So two negative terms are increasing. So obviously it will reduce once again. So your increased speed will reduce once again. Thereby your speed remains a constant. Your at full load condition, your speed will come back to no load speed. Okay. So that's why I can say at full load condition, your speed is equals to no load speed. So guys, try to understand why it is reducing, why it is the curve is reducing here. So because of this region, your n is reducing here. So this n, this increased n will reduce once again. It will come to same speed just like a no load speed. Okay. So tell me, am I using any extra controller for reducing your increased speed? No, it is happening automatically. That's very important point here. Okay. I'm not using any extra controller. Okay. So please let me write this point here. Differential compound motor has zero speed regulation. Why I am writing zero speed regulation? What is the formula for percentage speed regulation? Percentage speed regulation equals to no load speed minus full load speed by full load speed into 100. Okay. So guys, try to understand. Let me take no load speed at 1000 rpm here, 1000 rpm. And what about full load speed also? What full load speed also 1000 rpm only, you know? Okay. So 1000 rpm minus once again 1000 rpm by 1000 rpm into 100, it becomes how much? Zero only. Okay. So that's why I'm saying differential compound motor has zero speed regulation without any extra controller at IA rated condition. I'm writing at IA rated. See, at this portion at IA rated value, your speed full load speed is equals to no load speed. That's why your speed regulation is zero. Okay guys, so this point is very important. Same point he has given as a question in the GATE 2007 for 1 mark. Try to see this question. The DC motor which can provide zero speed regulation at a full load. At full load means what? At a rated armature current. without any controller is which motor? It's a differential compound motor. Option D is that. Very simple question. Okay. So please try to understand that. And can you please tell me? Can you please tell me where I can use this differential compound motor? It's a very rarely used motor. What is the reason? See, you tell me, guys. If you see maximum applications needs, so many applications needs, as load increases, your speed has to reduce. As load increases, speed has to reduce. Okay, just like a cumulative compound motor, shunt motor. Okay, so just load increases, your speed has to reduce. But the differential compound motor, if you see, as speed increase, as load increases here, as load increases, what will happen to your speed is increasing here. Okay, no application needs these type of characteristics. That's why differential compound motor is a rarely used motor. Okay, so please let me underline that point. I had given here somewhere here. Yeah, differential compound motor is a rarely used motor because as load increases, speed increases. No application needs this type of characteristics. That's why it's a very rarely used motor. So please try to understand, guys. Very important for examination point of view. It's a very rarely used motor. Okay, and yes, now I think for different for cumulative and differential, I explained N versus IA. In the similar fashion, if you approach mathematically, if you write an equation clearly, so you can draw T versus IA curve and N versus T curve also for cumulative and differential compound motor. Let us see for cumulative compound motor, T proportional pi into IA, where you know already pi means what? Pi S plus pi SC. And for differential compound motor, T proportional pi into IA, where pi means what? I can say pi H minus pi SC. And if you draw torque versus IA graph for cumulative compound motor, okay, as IA increases, if you see, your variation of torque will be just like this, just like a series motor is having some rectangle, parabolic variation, it will be like this, okay, for cumulative compound motor, okay. So already I explained so many things for series motor. By using that knowledge, you can easily know how to draw T versus IA. And for differential compound motor also, if you see, yes, I can draw as load increases, your torque ratio will be like this. It is going like this, and at large currents, your torque will be reducing in this manner. Okay, right. Now similarly, N versus T is just like N versus IA. For differential compound motor, I told it's N as IA increases, N is increasing, you know. For cumulative, as IA increases, N is reducing. So same thing I'm just writing here. As T increases, N value increasing. As T increases, cumulative compound motor N is reducing. Okay. So please try to understand. I think if you know basic, you just try to write equation correctly and try to write torque in terms of IA. You'll get this graph. You'll get N. Just write N versus N in terms of torque. You'll get this curve also. Okay. So right now, guys, right. And yes, let me explain cumulative applications here. The specialty of cumulative compound motor is cumulative compound motor develops high starting torque. See, you see here, I told you starting torque means where you have to see starting condition. I told you already in series motor while explaining. I told you starting means current will be very large. Okay, you have to see at large current region. That is only I can say starting portion. Okay. So guys, try to see this figure. This is what I can say rated value. Starting with somewhere here. So above rated armature current, starting torque means you have to see above rated armature current. You have to see somewhere here. Okay. So this torque is cumulative compound motor is having highest torque. So just like series motor, it is developing highest starting torque. So what is the specialty of cumulative compound motor means? Just like series motor, it develops highest starting torque. And just like shunt motor, its speed is no load speed is finite. See, if you want, you can see no load speed is finite. Okay. So no load speed is finite. No load speed is finite. So guys, try to understand. You are having some intermittent load applications. Intermittent means operation having both no load condition and load condition. So in those applications, definitely I cannot use a series motor. What is the reason? Intermittent means I told you no load and full load, no load and no load condition. Under not no load condition, you know series motor speed is infinite, so I cannot use that. And I cannot use shunt motor also because no load speed is finite, okay. But under load condition, it develops low starting torque. No, it's not like a series motor. That's why Obviously, what is the option for us which can be used for in intermediate applications? Just like a series motor develops highest starting torque, and just like a shunt motor, no, it's a no load, no load speed is a finite. So obviously, cumulative compound motor is the remedy for that, solution for that. In intermediate applications, a cumulative compound motor that develops, I mean, it is used because it develops high starting torque and its no load speed is limited. Therefore, they are better suitable for intermediate applications like punching machines, sealing machines, shearing machines, and printing machines. Okay, so better to remember applications. Okay, it develops high starting torque like series motor, and its no load speed is limited like shunt motor. Okay, shunt motor. So that's why I can use this motor in intermediate load applications. Okay, right. And if you observe clearly, I am just showing N versus IA graph for all motors in only one graph. I think you know, yeah, N versus IA curve, this series motor for it is rectangular hyperbola. I already explained. Let me show you once again, guys. Yeah, this one N versus IA means this graph. Okay, this graph only I am just showing here. Okay, and for differential, just now I told you, yes, it is increasing and reducing. So yes, differential count is as load increases, it is increasing. One side is coming back to same speed. No load speed and full load speed is I mean same here. And shunt, I told you as load increases, your N is reducing. It is having drooping at 6. And what about for cumulative? Just now I told you previous slide. This one, as if you want, you can see this one. N versus IA, no, yeah. As IA value increases, N value is reducing just for cumulative compound motor, just like shunt motor. Yes, let me show that here. So cumulative, it's not, if it's not visible, I'll write with white color. So cumulative compound motor, okay, right. Okay guys, so let me show all for all four motors N versus IA graph in each in only one graph. Okay, like this, if you see N versus T graph, same N versus IA graph and N versus T will be same. And let me show T versus IA graph also in only one graph. See guys, I'm just writing one point here. If all DC motors, I mean to say that series motor, cumulative, shunt, differential, all motors, if all DC motors designed with the same rated torque, means same rated torque at the same rated armature current, means the same rated armature current, T versus IA characteristics are as shown in the below. Okay. So guys, try to understand. I already show you series for series motor T versus IA means, if you want, I'll show you once again. For series motor T versus IA means it is a parabolic way, then linear. So that only I just showed here. It says mean parabolic, then linear. Okay, series motor. Okay, yellow color represents series motor. Okay. And for shunt motor, I already told you for shunt motor I'm saying it's a linear, no? Try to understand. For shunt motor, so already I just showed in the previous slide. So for shunt motor, T proportional to pi into Ia, where pi is constant, as Ia increases, torque increases in a linear fashion. Yes, this is for shunt motor. Green color is for shunt motor. And cumulative, just now I told you previously, cumulative see, T versus Ia. It's a first of all parabolic way, then almost all linear. Okay, see, parabolic way, then almost all linear. And for differential compound motor, yes, see, it's like this is a parabolic way. I mean, various will be like this. Okay, it will be like this, and at large IA values it is reducing. Okay, so please, yes, it is reducing like this. It is increasing and it is reducing above rated armature current. Okay. Okay, here one thing you have to understand. So if I draw T versus IA for all motors in one graph itself, so tell me, I'm asking some simple questions here. Okay. So tell me which motor develops highest starting torque, means what is your answer? Starting torque means you should see starting condition, what is the value of your current 1.5 to 2 times of I rated. That means above rated armature. You have to see somewhere here. Okay, let me use highlighter here. Yes. Starting torque means you have to see this region, because don't see here, you have to see here, because starting current means very large. It's 1.5 to 2 times of I rated value. So you should see somewhere here. In this region, tell me which, let me take at one particular load, tell me which motor develops highest starting torque here. It's easy. You can easily tell answer. Tell me which motor develops highest torque here. So first for series, okay, first for I can say series motor, then first for series, then for cumulative, then for shunt, then for differential. Is it okay for you guys? I think it is easily understandable, right? So if you're having doubt, let me write here. Yeah, at starting current means starting torque means you have to see somewhere here. I told you at above rate armature current. So at this particular point, let me extend this y-axis. So series motor develops this much torque, and cumulative develops this much torque. Shunt develops this much torque. Differential, it is touching somewhere here. Okay, it develops this much torque. Okay, guys. So please try to write this point. If all DC motors are designed with the same rated torque at the same rated armature current, T versus IA characteristics are as shown in the below. So at above, I can say at above rated armature current condition, at above rated armature current condition, tell me which motor develops highest torque. Series motor develops highest torque, then for cumulative compound motor, then for cumulative compound, shunt, then for cumulative compound, then for shunt motor, least for whom here? Least for differential compound motor. Okay, guys. So if they ask you at which motor develops highest starting torque, means you should go for option series motor, then cumulative, then shunt, then differential. Suppose if they ask a question like this, let us see. If they ask a question like this, let us see. Hey guys, if they ask a question at a below rated armature current, is very big careful, because this was a question asked in one PSU. So in that PSU, so many people went. I mean, they did wrong here. So please try to see. Yeah, at a below rated armature current means you have to see this region. So if all DC motors are designed with the same rated torque and the same rated armature current, at a below rated armature current, so tell me which motor develops highest torque, then which motor, then which motor, then which motor. Okay, so please, very simple question only, but try to understand clearly. Yes, let me use once again your blue color here. So at below rated armature current means somewhere here. So tell me which motor develops highest torque, guys. Which motor develops highest torque? So obvious differential. Differential motor develops highest starting torque, then shunt motor, then cumulative compound motor, least for series motor. Okay. So generally what people will remember, series motor having highest starting torque. That only they will remember. The statement is valid at above rated armature current. Okay. Suppose if they ask you specifically at below rated armature current, which motor develops highest starting torque, means obviously your answer is differential compound motor, then shunt motor, then cumulative compound motor, least for series motor. Okay, previously it is highest for series motor, at below rated armature current, least for series motor. So at above rated armature current, least for differential compound motor, at below rated armature current, highest for differential compound motor. Okay, guys, please try to understand. If you want, you can write same point here. At below rated armature current condition, okay, at below rated armature condition, so differential compound motor develops highest torque, then for shunt motor, then for cumulative compound motor, least for series motor. See, in one PSU they ask one question. What is that question? At below rated armature current, if all four motors are designed with the same rated torque at the same rated armature current, with below rated armature current, so tell me among shunt and series, which motor having highest torque, means your answer is shunt, not series. But so many people went for option series. That is not correct. So among shunt and series is having highest torque, that is okay. But in which case? At above rated armature current, in this region, series motor is having highest torque than shunt. But at below rated armature current, shunt is having highest torque than series. Be careful. So where is asking question, depending on that you have to react. Okay, guys. Okay. Yeah. In the next video, I'll be discussing some opposite questions regarding DC motors. Okay, guys. Thank you.